Let me present to you two scenarios. If someone offers you $1,000 today or $1,200 in 2 years, what would you choose? You want $10,000 in 5 years for a house down payment. How much do you need to start with today? The reason these questions matter is because money doesn't sit still. It changes over time. That idea is called the time value of money, and it's one of the most powerful concepts in business. Once you understand how money grows or shrinks over time, you gain a real advantage, because to create more money, you first need to understand how money actually works. To answer that question, there are three key factors that explain why money changes over time: inflation, risk, and return. Inflation reduces what money can buy. Risk reflects uncertainty about receiving money in the future. And return, driven by the interest rate, determines how fast your money grows when you invest it. If you're financially motivated and thinking smart, you want your money working for you, not losing value to inflation and risk. That's exactly why timing matters. The good news is, this doesn't have to be a guessing game. Once you know the interest rate and how much time you're working with, you can actually see what money is worth today and what it can turn into down the road. And the quick visual makes that relationship much easier to wrap your head around. This visual shows how money moves through time. We start on the left with present value, or PV. That is money today, the amount you have right now. When we apply an interest rate and allow time to pass, money moves forward. That top arrow represents compounding. Each period, the value builds on itself. As this process repeats, present value turns into future value, or FV. Time plays a key role here. It's not just passing. It's repeating the growth process over and over, which is why value changes. Now, this relationship also works in reverse. If we already know a future amount and want to understand what it's worth today, we move backward using the discount rate. That lower arrow shows the same process, just reversed. So whether we're moving forward to find future value or backward to find present value, the relationship is the same. The direction changes, but the logic doesn't. This is the core idea behind the time value of money. So how do we actually figure that out? We'll start with the first of two key formulas, the future value formula, which shows what the money you have today can turn into later if you give it time to grow. FV is future value, the amount of money you will have in the future. This is what we're trying to figure out in the equation. PV, or present value, is the money you have today. R is for interest rate, how much your money grows each year. And N is for time, how long the money grows, usually measured in years. Now back to our first question in the beginning. You're deciding between taking $1,000 today or waiting 2 years to receive $1,200. Instead of guessing, let's calculate what $1,000 today will be worth in 2 years using a 5% interest rate. Our conditions: present value is $1,000. Interest rate is 5% per year. Time is 2 years. Our formula: FV is equal to PV times 1 plus R to the nth power. Now if you plug those in, FV is equal to 1,000 times 1.05 to the second power. Now please take note that R is for the interest rate and a 5% interest rate is 0.05 in the equation, not 5. A lot of people can make mistakes from this, so just be careful in your computations. The result, FV is equal to 1,000 times 1.1025 or 1,102.50. 1,000 today will grow to 1,102.50 cents in 2 years. Now, going back in our decision, since 1,200 is greater than the future value of $1,000 today, waiting for the 1,200 gives you more value. Now that we know how to calculate for future value, what today's money can become, let's flip the question around. Present value, or PV, asks the opposite. What is money you receive in the future worth today? Just like earlier, the formula may look technical, but it's simply undoing growth over time. FV, or future value, is the amount of money you will have in the future. PV, or present value, is the money you have today, and this is actually what we're trying to compute in the equation. R is for the discount rate, how much your money grows each year. Notice also that here it's the discount rate. For the FV computation, it is interest rate because you're going forward. This one, you're trying to go backwards, and that's why it's called the discount rate. And N is for time, how long the money grows, usually measured in years. Now, consider the second question. You plan to buy a house in 5 years and will need $10,000 for the down payment. Instead of guessing how much to save today, you can compute for the present value, assuming your money can earn 5% per year. What are our conditions? Future value is $10,000. Interest rate, or in this case, the discount rate, is 5% per year. Time is 5 years. What is our formula? PV is equal to FV divided by 1 plus R to the nth power. Plug them in, and we get PV is equal to 10,000 divided by 1.05 to the 5th power. Just like earlier, be careful with the interest rate. It's 0.05. It's not 5. The total would be $7,835 today becomes $10,000 in 5 years. And as to our situation, investing about $7,835 today at 5% puts you on track to have the $10,000 you'll need when it's time to buy the house. At the end of the day, time value of money is just the reminder that money has a clock, and ignoring it gets expensive. The FV and PV formulas help you make smarter calls when saving, investing, or borrowing, and they're the foundation for bigger ideas like annuities and more complex cash flows. And that interest rate we've been using this whole time, that's compound interest, which is actually your best friend, even if it doesn't feel like it yet. We'll dive deeper into how it really works later. But once you get TVM, the time value of money, you will stop feeling bad about paying interest. Stop feeling awkward charging it. And start making money decisions with confidence and a little less stress.